Hello Tweedledees and Tweedledudes, Miss Norris here again to talk to you today about measuring angles. Welcome to episode 1 of the Measuring Angles series. So, grab a parent, grab a snack, and let's get started. The topic we're going to be discussing in episode 1 is how angles and fractional parts of a circle are related. The vocabulary we'll be going over in today's lesson are clockwise and counterclockwise. So, how are angles and fractional parts of a circle related? Well, let's first look at this circle. Did you know that a circle is actually made up of a whole bunch of angles? 360 of them to be exact.
Excuse me?
Don't believe me? Take a look. We call these central angles because the vertex is actually located in the center of the circle. Can you see that? But let's not get ahead of ourselves. Let's look at some central angles that aren't quite so overwhelming. Whew. That's better. Okay, so most of you are going to be able to look at this circle and say with confidence,
that circle has been cut into halves.
But what I want you to focus in on is the line going down the middle. It's actually an angle. Say what? Yes, look, it's actually made up of 2 rays and the vertex is in the middle. What kind of angle forms a straight line like that? Do you guys remember from our angles video? Did you say straight angle? Awesome! Okay. So let's take that same circle and slice it up a little differently. Now I have a circle that's been cut into fourths. But do you guys see a special kind of angle being formed by the rays inside this circle? Pay special attention to the corners that those rays are making. They're looking a little square to me. Did you say those angles are right angles? Awesome! This circle has been created by 4 right angles. Can you see them?
Okay.
Now that you guys are warmed up, let me show you the same circle but divided up into 12 pieces. Take a look at the size of each angle being formed in this circle. How could we describe or classify the angles that are being formed in this circle based on their size? Did you say they're acute angles? Awesome! This circle is made up of 12 acute angles. I am so impressed, you guys.
Okay.
Now let me see if I can fool you. Take a look at our circle again. I sliced it into 12ths again. However, this time I've combined 5 of those 12th size pieces to show 5/12ths of the circle. I want you to look at the angle that's forming 5/12ths of the circle. How would we classify that angle based on its size? Did you say an obtuse angle? Whoa! You guys are so smart. Now that you guys have seen the 4 types of angles that you're familiar with inside of a circle, do you believe me now that circles are made up of angles?
We never said that we didn't.
Great, let's keep going. It's your turn. Let's look at some circles and I want you to tell me what fraction of the circle is shaded and what kind of angle it makes. What fraction of the circle is shaded here? Did you say 1/2? Awesome. What kind of angle does it form? Did you say a straight angle? Fantastic. What fraction of the circle is shaded here? Did you say 1/4? Awesome. What kind of angle does this form? Did you say a right angle? Fantastic. What fraction of this circle is shaded? Did you say 1/12? Awesome. What kind of angle does this form? Did you say an acute angle? Fantastic. What kind of fraction in this circle is shaded here? Did you say 5/12? Awesome. What kind of angle does it make? Did you say obtuse? Awesome.
Excuse me, Miss Norris. Earlier in the vocabulary, you said something about clockwise and counterclockwise. Are you ever gonna go over that?
Oh, I'm so glad you asked. Let's look at our circle again. Now that you know how to recognize the fraction an angle represents inside a circle, I'm going to add some movement. There are 2 different types of movements that I'm going to want you to be able to tell the difference between. The first movement I want to go over is clockwise. We see clockwise turns and rotations in clocks. Watch the movement it makes. The direction goes from top, right, down, left, and then back up again. Look at these circles. Notice the arrows pointing in a clockwise direction. Clockwise, 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 clockwise. I know it's hard to imagine them moving when they're not moving, but you guys have the best imaginations of any kids I know, so you're gonna be okay. Aww. The second movement we're gonna talk about is called counterclockwise. The prefix in the word counterclockwise is the word counter. Counter means against or opposite. So counterclockwise means opposite of clockwise. This movement goes in the opposite direction of what a clock would move in. Watch the movement it makes. The directions go from the top, the left, then down, then right, then back up again. Look at these circles. Notice the arrows are going counterclockwise. Counterclockwise, 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 counterclockwise. It's your turn again. Check out this circle, but this time I want to know 3 different things. What fraction of this circle is shaded? Did you say 1/4? Awesome. What kind of angle does this make? Did you say a right angle? Awesome. What direction does it look like this angle is turning? Clockwise or counterclockwise? Did you say counterclockwise? Awesome. So what about this circle? What fraction of this circle is shaded? Did you say 1/2? Awesome. What kind of angle does this form? Did you say straight angle? Awesome. What direction is this angle turning? Did you say clockwise? Awesome.
Excuse me, Miss Norris, sorry to bother you again. What if the whole circle is shaded?
Oh, if the whole circle is shaded, you just say that one hole is rotating either clockwise or counterclockwise. After this video, I want you to go around your house and look for things that are spinning, like a fan or a washing machine. See if you can tell if it's moving clockwise or counterclockwise. Let me know down in the comments what you found and what direction it was going. I think you guys have got it. Join me on the next one when we start episode 2 of Measuring Angles. Bye guys.